Good evening and welcome to my channel. In this video, we will be executing some of the basic programs like Fibonacci series and Armstrong number program, because these are the most preferred questions asked by the interviewer during the technical interview. So without wasting any time, we will just start the execution part. If you do not have JDK installed on the system, you can use onlinegdp.com. Not only this compiler, you can use any online compiler and you can run your code fine. Okay. So as of now, the system is working fine. But sometime because of the internet connectivity issue, it does not work fine. Okay. Let me check again. Okay. So far working fine. Fibo series. In Fibonacci series, I'm just briefing you about, since you are here, you know much about Fibonacci series. Okay, we all know the concept of Fibonacci series. In that series, the first two terms are 0 and 1, and then all the terms are additions of previous one. Like the next term will be 0 plus 1, that's 1. Further next term will be 1 plus 1, 2. Then next 2 plus 1, 3. Then 3 plus 2, 5. Then 5 plus 3, 8. And in this way, the series will go on. So in this program, we will just ask the user that up to which term, up to which length you want the series to be printed, and then we will print the series according to the choice. Okay, so let's start. Still working good. We use three variables in Fibonacci series: integer n1, n2, and n3. As stated earlier, we define n1 as 0, n1 is equal to 0, n2 is equal to 1, and we do not initialize n3 by any of the mean. Okay, because we will be incrementing this throughout the series, throughout the term. We will first print n1 and 2. Why we will print? Because every time we will be doing, the value of these two will remain constant. And just notice properly, I am using system.out.print and not println, because I do not want to print at new line. Okay, I want the program to give me the output in the same line throughout. Now what I am gonna do here, I am gonna use a for loop in which I will say integer I, which will be starting from 2. Why 2? Because 0 and 1, these two terms are initialized earlier. So I will start with 2. And till what I will do, I will perform till the time my test case does not overflow. That means the part of t. What's the role of t? I will just brief it. Now only we will use a scanner class to accept the input. Okay, like okay, let me does not include the scanner class. Let's say I want to print the Fibonacci series till 7 terms. So the value of t becomes 7, and this is my basic loop. And what I will do for each term, just like I said, that if my first term is 0, next term is 1, the further terms will be 1, then 1 plus 1, 2, then 2 plus 1, 3, then 2 plus 3, 5. That means n3 will be the addition of n1 and n2. So I will write here n3 is equal to n1 plus n2. Is it enough? No, I will print this. So I will just copy, I will just then paste it over here, and I will paste n3. And just to make it proper, I will use spaces to separate all the numbers. And what will I do now? I will change the variables. Like my n1 will be initialized to 0. That means that my 0 will be initialized to 1. My 1 will be initialized to this one. Okay. So my n1 will be equal to n2, and my n2 would become now n3. This is all about your Fibonacci. Let's print this and check whether it is giving the correct output or not. What is the error? Semicolon missing. Be aware. And as you can see clearly, 0, 1, these two terms, and then 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8. What if I would have used print ln over here? Then this is not the Fibonacci series we know, and this is not the proper way to write, and hence I said we will be using only print function. This was for Fibonacci. Well, I don't know how to use comments here. Let me just check. Yes, I can use it properly. Because this was all about Fibonacci. Let's try to write the code for okay. So let's write the code for Armstrong number. Armstrong number. What this code mean about? And I hope you all know the definition of Armstrong number. But in case if you do not know the definition of Armstrong number, let me tell you 153. If this is my number, then what's the sum of cube? Sum of cube means this is the definition of Armstrong number. Cube of 1 is 1. Cube of 5 is 5 square 25 raised to and cube 125. Okay. And then 3 3 is 9, 3 is 27. This sum comes out to be 7 plus 5 12 plus 1 13 3 remaining 1 12 and 2 14 15. Okay. This comes out to be 153. So what we conclude from here? The sum of cubes of digits of that number, if comes out to be the number itself, then we can call that number as Armstrong number. Okay. A bit more perfectionally if I speak about, then Armstrong number is a number that is equal to the sum of the cube. So how to write the program for this? Here also we will need some of the part. Like here we need, let's say if we use only 153. Okay. I say that my number integer m is equal to 153, and then I will just use my number like integer n is equal to m. I will store the number, store the value 153 in another variable. Okay. And now what I have to do now? I have to write the code in such a way that till the time my m does not become, okay, I will just clear all the concept of yours. What I will do, I will here just take out 3 first. I will find the cube of this. Okay. Then I will sum it with the cube of 5 and then with the cube of 1, because this is what my Armstrong number mean about. Now in case if you don't know about how to pull out the last digit of any number, if you simply use that n is equal to n mod 10. Okay. If you use n mod 10, then this will give you the last digit of the number. Let me explain you how. Answer the question. 4 mod 2. 4 mod 2 gives you the answer 0. Why? Because 2 completely divide 4. Okay. But if I'm using n mod 10, the value of n is 153. 153 divided by 10, 153 divided by 10 will comes out to 15.3. That means till 150, the 10 divides completely, but 10 does not divide 3 completely. So 150 mod 10 will generate 3. In this way, I will use all the digits. Next, I will store r plus no yr. I will use a sum variable s that will be equal to sum plus let me store in different variable r cube. So r into r cube. And every time I will do this, then I do not want 153 ka 3 to be repeated again. I will divide 153 to make it 15. Okay, every time. So I will say, sorry, my n is equal to n divided by 10. So my 153 will become 15. Then 15 will become 1. Okay. And if 1 divided by 10, the answer will be 0.1. And 0.1, I do not need dash to be done. So I will say that repeat the process till the time my n is not 0. So I will use a while loop and I will say while my n is not equal to 0. Kindly perform this all task. Okay. Now what to do? I have used this. I have to then initialize integer r, integer sum is equal to 0, comma r. Because these are the two variables I have used. Then what will I say? That if my s equals to m, then I will print, let me copy this here, copy, system.out.print Armstrong. Okay. And in the else case, I will say, let me tell you also one thing. If you are using the single statement in if else loop, you need not to use these curly braces. You can directly write. And what I want, not Armstrong. Let's check. Okay. Run. Expected. What expected? Expected this. This would be expected here also. Now let's run. Why Armstrong? Because my number was 153. Okay. Now if you want the number to be taken, to be given by user, you will use scanner class. Scanner sc is equal to new scanner system.in. Okay. And then you will say that integer m is equal to sc.nextInt. Let's see what does it give something. As I said earlier, cannot find. Why cannot find? Because I have not included this. So I will simply say import java.util.star. Run again. Let me input the number, say 12. Yes, I'm inputting the number as 12. And let me check whether it is Armstrong number or not. We all know that this is not an Armstrong number. Okay. And the code is printing the same, not Armstrong. Guys, let me give you a small trick over here. This was the code for Armstrong number. If you are asked that find the sum of digits, then you have to just make a small change. What small change? Done. Okay. And you need not to use all this. You have to simply say sum of digits plus this. Let's check whether it is working or not. If I does not include this over here, and if I say, let's take the same example of 153. The sum of this is 5 plus 3, 8 plus 1, 9. Okay, so let's check. As I said earlier, I do not have much sufficient Wi-Fi connectivity, so it's taking some time. But it should give the right answer, and you can see it is giving me the right answer. Okay, so this was all about these three things. Thanks for watching. I will stop sharing. Thank you.